Hi everyone, welcome to our seminar today. We're talking about introducing new technology in manufacturing. I'm Melinda Laundon, the postdoctoral researcher for Program 5, the Human Robot Workforce, and you'll be hearing today about the research of our 4 PhD candidates. I'd like to start by acknowledging the traditional owners of the land on which I'm located and the other presenters are located today. That's the Turrbal and Yagara people as the First Nations owners of these lands. We pay respect to their elders, laws, customs and creation spirits and recognise that these lands have always been places of research and teaching and learning, and QUT acknowledges the important role that Aboriginal and Torres Strait Islander people play in the QUT community. So this is just some information about our research program, which is led by Associate Professor Penny Williams and Professor Greg Hearn. There's a list of PhD candidates that you'll be hearing from today as well. So today's workshop focuses on introducing new technology in manufacturing. Specifically, we're looking at the workforce implications of cobots. As many organisations are aware, adopting advanced technologies such as cobots is no longer just a technical decision. So it also raises important questions about workforce readiness, job design, and how organisations can ensure these technologies deliver real value. So Program 5 focuses on understanding the human side of cobots. Our research examines several key areas, including future skill requirements, the design of work and jobs, how organisations prepare for implementation, and the role of workforce diversity in supporting sustainable adoption. So this work is conducted by an interdisciplinary team of researchers, and we all contribute different perspectives. So today's session is structured around 4 key themes. First, we'll look at the key factors that influence the adoption of cobots. Second, we'll examine cobot usage and work design, focusing on how jobs change once these technologies are introduced. Third, we consider the role of workforce diversity in shaping the future of manufacturing work. And finally, we explore future skills gaps and workforce development needs. So I'll now pass over to Nisar Channa to tell us about key factors in the adoption of cobots.
Thanks everyone for joining today. So I would be giving a brief overview about what are the key factors of cobot adoption. So adopting a cobot is not just a single purchase and go initiative. Rather, it's a strategic integration, and its success depends on 3 main factors. So today I would be discussing those factors, the strategic and economic factors. These factors answer the why question, why we are actually adopting the cobots. Then there are some technical and operational factors, and those factors are related with the how factor, how cobot would be integrated, and what are the factors, organizational factors that are addressing the how question. Then there are human and organizational factors, and these factors will answer who are the key stakeholders, who are the people, who are the things that gonna be affected by the cobots. So answering strategic and economic factors, there should be a clear business case and a return of investments. So one should be clear what are the specific problems that they want to solve with the cobots, whether these are bottlenecks associated with the production system. Are there any quality issues that company want to resolve by having a cobot, or is there any ergonomic risk associated with the existing manufacturing systems? So calculating total cost of ownership versus return of rate of investment. So here we address what are the hardware, software, and integration issues. What are the hardwares that we need? What kind of software systems we need for successful integration? And then there should be strategic alignment. So this strategic alignment should address uh, whether this initiative of adopting a cobot will address the broader business goals. We need to align our business goals with the cobot system. So, what are our business goals? Are we aiming for reshoring? Are we having issues with quality excellence, or we want to enhance the quality excellence, or we want to focus on Industry 4.0 technologies to enhance our manufacturing output, or whatever? So there should be also some financial justification. What are the upfront investments and what are the long-term savings? So whether our investment is giving us enough rate of investments by reducing the scrap, higher throughput process, or less downtime in production systems. So with technical and operational factors, we also discuss task suitability and feasibility. Is the task repetitive, tedious, or physically demanding that manual labor or human labor cannot do in an appropriate manner? So, is the workplace is predictable and structured enough? So then we also need to consider whether the integration is seamless with existing systems that we are having at the moment, how it will connect with current systems, machineries, softwares that we are using at the moment. So here the interoperability is the key. So our existing systems should be work in harmony with the new cobot system. So if we are having this interoperability, then this integration would be seamless. So safety and risk assessment is also mandatory here. Even collaborative robots require safety measures such as light curtains, speed, force monitoring, etc. So ease of use and programming also matters here. So companies need to address whether their existing workforce be trained to program and troubleshoot the cobot system. So the most importantly, workforce and organizational factors. This factor is the most critical and often overlooked by companies. So the company should also consider workforce dynamics and change management practices there. So addressing the fear factor among the workers would be helpful in a seamless integration of cobot. So companies need to address will robot take the labor jobs, or so they need to clearly communicate this with their workers, that robots will not take their job, rather robots or cobots will make their jobs more easy. So again, communication is a critical factor here. So frame cobots as a tools that augment and assist labor jobs, not to replace them. So training and upskilling is also a critical factor here, where shift from manual labor to robot management, programming, and maintenance should be focused. Employees or workforce should be communicated clearly that uh, this adoption will empower them uh, to lead their jobs uh, in a more engaging way. So empowering their workforce would always have higher adoption rate for companies. So companies should also consider what new jobs or new job roles or new job designs will come up. So creating new positions like cobot technician or automation coordinator. So these are some examples of the new jobs or new job roles that might come up. So company leadership and culture also plays a critical role here. So if the leadership owns the project, leadership champion the project, so this would be great for companies for a successful adoption. So we got some this important implementation roadmap. So we have 6-point checklist here. First, companies need to identify and select what are the pinpoints, high rate of investment, what are the suitable applications for cobot. So in second step, companies should have a feasibility study where they need to conduct a study about technical and economic analysis. What are the technical issues that companies want to solve with the cobot systems, and what are the economic implications for that? So in step 3, there should be a proof of concept where companies need to run a small pilot project with Cobot to see how Cobot is performing the task that they want to automate before a full-scale adoption. So in step 4, it is wise to plan and prepare for a wide-scale adoption. Develop a full project plan, include change management and training systems. Whereas in step 5, this is related with implementation and integration of installing program and conduct safety, risk assessment, etc. Similarly, in step 6, companies need to have a scale and optimize where they need to monitor performance, gather feedback, and identify new applications. What are the new systems, tasks, and new applications that might come up with the robot, and they want robot to perform those applications. So here I would also like to highlight some pitfalls that companies need to avoid. First of all, treating cobot adoption as a pure IT project and ignoring the problem. So this is one of the main problems why there are some failures of adoption, where people treat this adoption as purely an IT project, where they are ignoring the human or the people aspect of this adoption, because after all, workforce is the main stakeholder in this that gonna be affected by this adoption in the companies. So second pitfall is companies they don't have a clear business case or unrealistic rate of investment expectations. So they just invest money and they think that cobot will solve all the problems, and they don't have a clear case study what they actually want cobot to do for them. So that's also one of the important pitfall here. So third, companies choose the wrong application. That might be too complex for a first project, and as I earlier said, they think that cobot will do every task for them, everything for them, which is in real terms, which is not the case. So they need to clearly choose the application that they want robot to do for them. Then some companies, they skip their formal risk assessment and safety protocols, and they will just think that cobot will look after all the things, which is not actually the case. So they need to conduct a formal risk assessment, and they need to think about what are the safety protocols for them. And then there is lack of internal expertise and long-term support plan for the companies. So these are the 5 main pitfalls that need to be avoided. So the future is collaborative. Cobots are becoming smarter, more sensitive, and easier to use. And AI vision systems will enable more complex and adaptive tasks for cobots. So in future, the focus will shift from automation to a true collaboration where humans and robots will leverage their unique strengths. So the goal is not to create a fully automated factory with having a lot of robots and cobots and everything is being automated. But here the focus is to build a more productive, safe, and engaging workplace where humans and machines work collaboratively together to achieve the overall goals of the company.
Thank you, Nisar, for sharing those insights from your PhD research. So in this section, I'm going to present you an overview of the work of PhD candidate Phuong Anh Tran, who's currently on parental leave, but will be returning to her PhD in 2027, and will be looking for industry partners at that stage to research with and test some of her work design concepts. So basically, work design is concerned with how jobs are structured. Effective work design can balance the needs and capabilities of the people involved across multiple characteristics of work. So Phuong's PhD is a joint Cobotics Centre and CSIRO PhD. It investigates workers' experiences of working with cobots or other robots and how organisations can design work in a way that maximises the benefits while minimising risk. So Phuong has conducted a large-scale and extensive project to map cobot use across Australia in a way that hasn't been done consistently before. So we can see that adoption is distributed across multiple states and across a wide range of subsectors, which includes food and beverage, metal fabrication, electronics, and advanced manufacturing. The types of tasks where cobots are being introduced tend to be labour-intensive, repetitive, and require high levels of precision and consistency. So one of the most commonly reported impacts of introducing cobots is process redesign. Introducing a cobot often changes how work is organised, including workflow, task allocation, and the sequencing of work. This can lead to efficiency gains, but also requires organisations to think again about how human and machine contributions are coordinated. A second area of impact relates to physical demand and safety risks. Cobots are frequently used to reduce or remove repetitive manual tasks, which can lower injury risks and exposure to physical hazards. But from a work design perspective, it's important to ensure that risks are genuinely reduced instead of shifted elsewhere in the system. So this highlights the importance of careful job design and risk assessment alongside technology adoption. Finally, in work design, we look at the third reported impact of cobot adoption concerning job characteristics. So in some cases, cobots might enable workers to shift away from tedious and repetitive tasks towards higher value or more meaningful work, such as monitoring, coordination, or problem-solving activities. But whether this leads to more meaningful and engaging work or not depends on the way that jobs are designed. Without careful attention, there's also a risk that people's jobs can become more fragmented, overly simplified, or tightly constrained. Jobs can be enriched by the introduction of cobots, but this needs to be managed carefully. So this is why Phuong's research emphasises that outcomes aren't determined by the technology themselves, but instead of the way that work is designed around these technologies. So this brings us to the central point about the importance of work design. So when work design is done well, it contributes to meeting workplace health and safety obligations, saves money, drives performance, and prevents workplace issues, and ensures that technology achieves that return on investment while minimising unintended harms. Phuong has also developed a work design impact checklist and has started to test this in some organisational contexts and will continue to do so when she returns next year. This provides a practical way to think about work design. It's research informed. It can support organisations in identifying key work design considerations before, during, and after the implementation of cobots. So the work design impact checklist has these 4 broad categories, and some of the specific key questions within it include: how are we considering work design during the planning phase? Have we clearly identified which tasks are best suited to cobots? When cobots take on certain tasks, have we defined what people will do instead and whether these roles will remain meaningful? And how does the redesigned job affect worker autonomy, decision-making, and day-to-day control? So rather than asking whether a technology can be introduced, the more important question becomes: how do we design work that's safe, effective, and sustainable for the people working alongside the technology? So I'd now like to hand over to Akash.
When we come to my research area, the diversity is the main problem. Is when researchers are talk about the diversity, mostly talk about the gender diversity. So the most of the researchers are focusing on gender diversity and ethnicity as well. So the main challenge when I started my research to understand the real complexities in diversity. So there's a literature gap that because most of the researchers are using ABS raw data to say that it's male dominant or all the manufacturing is getting old are very common kind of a discussions goes on. So I try to find it out how complex is that. So the manufacturing industry in Australia is having a 16 subsectors which are really varies from food manufacturing to steel manufacturing, chemical manufacturing, and all. So if you go to the gender diversity, so my main objective on this study is to be show that for the future researchers, so how complex is the diversity in terms of gender, in terms of generation, and other areas as well. So, but as a result of this analysis, I have found that the gender and the generations are the key areas manufacturing sector is currently challenging. So when you go to gender diversity, the occupational gender segregations are one of the key things. So most of the clerical jobs, administrative jobs are for uh, uh, women, and technician trade workers are really low representation of women as well as the laborers. So this comes from so how the industry is attracted and how the industry is working for a long traditional way, the processes and all. So in my latter part of my research, I'm going to looking on that how designers understanding of diversity and how business leaders are getting challenged diversity as well as the workers what their experience on diversity. So when I go to the qualification sector, which I have seen that the future with these technology developments and with advanced technologies, so most of the discussion goes on that skills has changed. So when it comes to skills, the qualifications also matters. So most of the uh, uh, current manufacturing workforce is having a pyramidal level of education and very less kind of a graduate and the diploma level or higher educated people who are getting engaged with. But with the technology change, so this might be a factor. So are we going to get a digitally enabled workforce with the existing workforce? So we need to have a think about that. What kind of a future workforce when we are going to introduce the technology in a continuous growing way? We have to be really careful about that. So whether expected level of skill and skill changes and job changes are these existing qualifications are adequate, or do we want to have a different kind of a qualifications? The other thing is, so most of the manufacturing jobs are permanent jobs. So very rarely temporary jobs because manufacturing processes are really complex and need to have a kind of a very special skills because it's a kind of a process driven. So it will take a lot of time to be adhere to the process. So this is also in another way getting young employees to be entering to this manufacturing jobs. They might be getting their first job with some other areas, and they will fix their job on that same sector, and they don't want to move again to the manufacturing. So the as a pipeline of labor supplies, so this might be an area to be considered. So this whole set of findings which we have already published in Equality, Diversity and Inclusion Journal, the Q1 EDI journal, and you can read that and find it out what this data set says and how it is important before you start researching on diversity on manufacturing. So let me hand over to Jacqueline for the next part.
So you've already heard a lot about how we're changing jobs and how qualifications might be changing and the different skills that are required if our workplace is becoming more technologically advanced and engaging with different technologies such as robots. And so what we've been finding is that there is an evolving need for trade qualifications higher than the traditional trade qualification that many people in manufacturing have, such as Cert 3 and Cert 4. And what we've also found is that there are new partnerships trying to meet some of these needs that are occurring between vocational education and higher education. And so talking to colleagues down at Swinburne, where they're looking to develop, being dual sector, they have the opportunity to develop some of these more hybrid type qualifications or qualifications that sit in between. There's a lot of work going there, but not always the funding that's coming along with it, which is a bit of a challenge. However, to meet some of these different needs, then other kinds of skill solutions are occurring, which include things like micro-credentials and skill sets. So skill sets are made up of a small number of competencies within a standard certificate qualification that provide people with particular skills. But particularly micro-credentials are emerging as a short skilling, upskilling mode, which the Cobotics Centre has already been involved in, particularly with Weld, and that's had some really good outcomes, which I know, talking to Cornelius yesterday, John, he's keen to share the outcomes of that. And there's been some really so they have a place in educating people in small gaps of skill. However, the biggest skill set that people are going to need to work with these jobs are likely to require a higher skill level because of the complexity of the skill required. So that's including things around your mathematics and your literacies and things like that, the problem solving, and the adaptability to be able to move across context rather than staying within the same context. So as the technology evolves, the worker needs to also be able to move with the technology. It is interesting how the technology drives the work, though. And so for Industry 4.0, we will still need some of these traditional and technical skills that have been there. People will still need to understand, for example, welding and how to weld and what a weld looks like. However, the technology will be undertaking some of the different kind of skill that people currently do. People will need stronger transversal skills. So these are skills that cross boundaries and are transferable. So some of the way that people think about even using programs. So I do know that in TAFE and even in schools, people are taught particular softwares to be able to solve or work with particular kinds of technologies or problems. They need to be able to adapt those skills across different contexts and different ways as these things continue to emerge and grow. And the soft skills needs are increasing. So that's things like teamwork, communication, problem solving, those kind of skills beyond the technical skills, and more needed now because of the type of work that people undertake. And so what a lot of workplaces now need to do is to consider not only the technical skills that they're going to need in their workplace, but also those transversal and soft skills that people are going to need to be able to work across the different platforms and the different kinds of work that people do. And so what we do need to remember when we do this is we've become really good at teaching hand and technical skills because that's where manufacturing has sat in that more tailorist kind of way of thinking about work, where it's broken up into particular groups of tasks. Whereas now we need to be able to teach people to think across more broadly beyond just the competence or the thing that's happening here and now. They have to be able to understand and to be able to work in different modes in different ways. And often these soft and interpersonal skills are going to be harder to assess and to recognise in teaching. And so that's going to be a challenge to continue for training and training programs about how we recognise, teach and assess these different kinds of skills.
So thank you to all of our presenters today for presenting insights from the past 3 years of their research. We've only had time for a very quick overview, but if you would like to know more, please get in touch with us through the Cobotics Centre. So to close, I'd like to return to the broader purpose of our work in the Human Robot Workforce Research Program. So today we've explored cobot adoption not simply as a technological shift, but as a transformation in how work is organised, experienced and valued. So what emerges from our research is that the success of human cobot adoption and collaboration doesn't just depend on the technology alone. It depends on how organisations design work, develop skills and support their workforce through the change. So please get in touch with us if there's anything else you would like to know, and we also have time for some questions as well. Thank you. Do we have any questions?
There's a hand. Oh, that's a clap.
Nisar, can I ask you one question? I've been interviewing our different industry partners, and a constant, it's not a question, but a constant consideration is about productivity and productivity improvement. How do you see that fitting into what you did?
Mainly my research was not about productivity or production enhancements. Rather, I was more focused with the adoption surrounding with the three main areas: workforce, organization, and technology. So I didn't found anything related with the production or productivity enhancements in particular.
So, if that was one of the considerations that came in when you were...
If you change the wording slightly and talk about efficiency rather than productivity, then that you might be referring to that, because productivity is like a bigger strategic kind of thing that you have to measure over time. But in terms of efficiency, that was basically probably the main presenting rationale for just about every person that we talk to in the research, but also it's what the literature we found suggests as well. And basically, there's a lack of imagination in my view. It's like we have a problem, but we think about it like an industrial robot.
Yeah.
We need to replace a human with an industrial robot. And obviously, we all know that cobots can do many other things and offer all kinds of things. So I think, as a general comment, I think that, manufacturers are so used to thinking about automation and let's lower the labour input and improve the machine input, that's their default setting. But if you think about it, that's kind of like only in terms of the value proposition for what they're manufacturing, that's a cost. That is a cost benefit that they could potentially bring about, right? So, but cost is, if you think about what you buy, cost is only one reason why you buy things, right? So quality would be another one. Okay, innovativeness would be another one. Does it do something different than all of the other products, right? So whilst I think manufacturers are stuck in, we must reduce our costs, and that's the only competitive advantage they've got, they will tend to think about automation and efficiency. And it's kind of the de facto way that people think about it. So one of the things that we found later in Nisar's work was the importance of whether or not there was an innovative and creative culture in at least some parts of the company. And then you could get into other kinds of things like enhancing product features, for example, or designing product features in a completely different way, or even coming up with different revenue streams as well, different kinds of products or services attached to it. Yeah, I think it's really interesting. It's kind of shocking when you see the literature and you also talk to people a lot and you find out that that's really the only way people can think about doing it.
Yeah.
If you look in, I think if you look in the health sector, for example, there's a very much different approach. They're not stuck on just let's automate everything, right? They're much more understanding of the fact that what they're trying to do is a more complex, socio-technical kind of problem. Doctors don't immediately think of what's the cheapest way we can do this hip replacement, right? There are a lot of other outcomes that are taken into consideration. So there's room for manufacturing in Australia to sort of migrate to high value manufacturing, I think, yeah. read Nisar's second paper.
Okay.
And because there's so much change in technology, do you think they're paralysed? Because I think whatever is coming next will be out of date within a few years. I mean, like cobots, probably actually not going to be a big thing because humanoids will probably be the big thing. So if I was in business, I'd be nervous about investing in cobots, thinking that in a couple of years
What do you reckon?
they're not going to be a thing anyway.
What do you reckon?
So
Do you reckon we found that in the interviews?
yeah, is there any indication
So,
that?
a lot of people were talking about that technologies are getting obsolete so quickly.
Yes,
like
okay,
the rollout of technology,
yeah.
the tech, what they call it, the span of rollout, it's become shorter.
Yes. Yeah. But do you think that then makes people do nothing?
Unless something becomes so pervasive like AI where they feel like they'll be left behind, so they jump on it immediately. Which prevents them from being able to invest in other technology.
I mean, manufacturing in Australia is like 99% is less than 20 people, and probably half of manufacturing is just a family company. Right?
Yeah, that's right.
So cost and efficiency is like a live or die kind of issue, right?
Yeah.
So to fork out 150 grand for a cobot is a big consideration. But if you go to the bigger end of manufacturing in Australia, I think that's where there are opportunities for people to do really interesting and more innovative things that not only going to change their cost basis, but also change the value proposition of what they're doing, right? Which, as I said before, is not just about how much something costs. Well, we buy things for all kinds of different reasons apart from cost. And so you really have to think of continual adaptation and continual innovation if you're in high value manufacturing. And there's an opportunity there. I don't think we've discovered anyone who was worried about humanoids yet.
No, we haven't.
But that's just because it's so new, right?
Right, it is. That's right.
And I think they're going to maybe have a different... Look, there is something about, like, it's a little bit like saying, I don't know, vacuum cleaners meant we don't need brooms anymore. Right, it's not right.
We need both.
We need both, because one is more practical and easier. You don't have to plug it in. And it's just for a quick this, and the other one is more complex. It breaks down more often, whereas... And so I think that's what you find. So I think actually I would suggest that, cobots and humanoids maybe are going to operate in slightly different ways and contribute to different kinds of things in organisations. And if if you've had success with the cobot, as a lot of people we talked to had, then you're feeling quite confident, I think, that you're going to be able to use that in a way going forward.
I think another thing, John, is that, like, talking to the TAFE teachers as well, like they were talking about Australian business as a whole operates, and if you think about even the university sector, it operates on risk.
Yes, totally,
So unless they can get the risk as low as possible, then they're less likely to invest. And until they understand that risk level, then they won't engage with it.
Yeah, but when it's a fast-moving thing, it's probably hard. It's hard to figure out.
That's right, and that's why they come first.
That's right.
So I think the main thing that we have found out when we were talking about spectrum of adoption with the company, so main thing they were talking about, it was return on investments, like what initial investment that we are putting in and how much we are getting returns on the technology. So if you are talking about cobots and humanoids, so what is the cost difference between them? So which is more feasible for them to get returns on investment? So I think that was the main point. A lot of companies were talking.
I think this one, like this was Nisar, was one of his personal kind of insights, and I think it's something that people don't talk about much. This idea of spectrum of adoption. It's not an all or nothing thing often,
Yeah, it can be that pilot testing. Okay, well, I think we're nearly out of time, so we might have to wrap it up there, but thank you everyone for coming.
Thank you.